right, so now we're in the logarithmic properties. Have to keep the jokes going. I hope you've seen the previous jokes. Need to get a little laugh every once in a while. This is pretty uncertain times, but we're going to get through it. I know we can. So let's go ahead and start talking about logarithmic properties, okay? So we're going to start with the product property, and as you can tell that when we have log base b of m times n, it's the same thing as log base b of m plus log base b of n. All right, so we're going to go ahead and do some of the examples right here where we would have log base 3 of 9 plus log base 3 of 5. So that property is telling us that if we have the same bases right here, then we take whatever inside the logarithms and we multiply them. So that's what we're going to do right here. So then we have log base 3 of 9 times 5. Well, 9 times 5 is 45. So your final answer is 45. Now remember, we are condensing into a single logarithm, so we're making it smaller. This is one single logarithm. All right, on the next one, we have log base 6 of, log 6 plus log of x minus 3. And one of the things I wanted to point out, how important it is to use your parentheses. Because if I was to write log x minus 3, that would mean something totally different. So let's be careful with our parentheses. So this is saying that we're multiplying these, so it's going to be a single log of 6 times the quantity x minus 3. So we go ahead and we distribute, and we end up with log 6x minus 18. Now, I had made a video that was called 6.48 to the review of exponents. And so if you need to watch those, because I'm not going to go over it too much in this video. So if I've got natural log of 4x squared plus natural log 3x cubed, just as a reminder, what we had learned is that if we have log base e of x, that's the same thing as natural log x. So we go ahead and we multiply those together. So we have 4x squared times 3x cubed. We end up multiplying that, and so the rule of exponents, we have 12 because 4 times 3 is 12, but the rule of exponents is 2 plus 3, so our final answer would be natural log 12x to the 5th power. All right, now we're expanding. And when we expand, we go ahead and we have it all the way down to prime numbers. So if we have log 72, I know that 8 times 9 equals 72. So then we would have log 8 plus log 9. And if we put it all the way down to prime numbers, we know that we have log 4 plus log 2, because 2 times 4 is 8. And then we know that this would be log 3 plus log 3. All right? We can continue on all the way down to the prime numbers. So we have log 2 plus log 2. All right? And we can go ahead and put this as 3 of the log 2's, and there's 2 of the log 3's. Okay? Which you're going to notice how this property is going to work later on. All right? On this one, we know natural log 9/10 well, 9 times 1/10 equals 9/10. So then we would have natural log 9 plus natural log 1/10. And based on what we did right here, this would be 2 natural log 3 plus natural log 1/10. Log base 5 of x squared minus 4, this is difference of squares, and I'll write it all out so that you can see the steps. So we have x plus 2, x minus 2. If we were to FOIL that and multiply, it would go back to this. So then we would have log base 5 of x plus 2. See how important it is to have the parentheses? Log base 5 of x minus 2. All right, so that's the product rule. Now the quotient rule. The quotient rule tells us that we have log base b of m over n, which would equal log base b of m minus log base b of n. So whenever we go ahead and we work on these problems here, we have natural log of 96 divided by 6 because we're dividing since we're subtracting those. Remember, we're getting it into one single logarithm. Well, 96 divided by 6 equals 16, so this in turn is natural log 16. Log 8 to the 10th power minus log 4x squared, or sorry, I don't know why I'm having such a hard time talking. Log 8x to the 10th power minus log 4x squared. So since we're subtracting, whatever's inside the logarithm, we're dividing it. So based on this rule that we have, so 8x to the 10th power over 4x squared, which we know that 8 divided by 4 is 2. And remember the rule of exponents, it's 10 minus 2. So then our final answer would end up being log 2x to the 8th power. All right, on this one, we would have log base 7 of square root 40 over square root 5, which in turn we can write this. This is something that you had learned in Algebra 2. You can write it as one single logarithm. So then we would have log base 7 of square root 8. And just as a reminder that if you got square root 8, that's the same thing as square root 4 times square root 2. So our final answer here would end up being log base 7 of 2 square root 2. Now we're going to be expanding. So we know that 8, we would have 2 times 2 times 2. If we get it all the way down to the, oh wait, this isn't it. This is dividing. So we're trying to figure out what equals 8. So then we would end up having to maybe say, well, you have 16 divided by 2, which equals 8, or you can use 24 divided by 3. You can use any of those, but I'm going to go ahead and use the 16 right here. 16 divided by 2. So then we would have log base 3 of 16 plus, or excuse me, minus log base 3 of 2. So we can go ahead and we know that 16, let's see, 2 to the 4th power equals 16, or 2 times 2 times, when it's multiplied 4 times, that equals 16. So then we would have log base 3 of 2 and then I ran out of space. So then if we have this minus this, then it would end up being just these 3 right here. So then it would be 3 times log base 3 of 2, okay? If you go ahead and leave it like this, that's okay. I will accept that. I'm just wanting you guys to be able to see that there's going to be several answers, but once you get it all the way down to the prime numbers, it ends up being all the same. So if you say log base 3 of 24 minus log base 3 of 3, that I will accept that, okay? You don't need to necessarily do this stuff just yet. Maybe later, but not just yet, okay? All right, so let's go ahead and look at this one. Natural log 3 over 4, so natural log 3 minus natural log 4 is all you would have to do here. This one is log x minus 7 minus log x plus 1. So that's all you would have to worry about on that one. All right, now the power property. Power property is if you got log base b of m to the n power, then it's going to be whatever that exponent is times log base b of m. So what's happening is that it's going this way. Or with this property, it would go back this way. All right? So on this one, we're having to condense. We're going to be expanding. Let's look at condensing first. So if we've got 3 times log 6, that's the same thing as saying log 6 to the 3rd power. Well, log 6 to the 3rd power is 216, so that's our final answer. Log 216. All right, remember the rules in Algebra 2. If you got 81 to the 1/2 power, that's the same thing as saying square root 81. So that's what I would put right here. So log base 4 of square root 81, well, square root 81 is 9. Okay. On this one, we have, we're going to put this up in the exponent. So it's natural log 4 to the power of x minus 1. All right. Now we're expanding, and when we expand, now we're going the other way, this way. So this would be x times log base 2 of 5. And since we know that the cubic root of 2x plus 1 is the same as 2x plus 1 to the 1/3 power. So in other words, I guess I can go ahead and write out each step so that you can see this. All right, so then it in turn equals 1/3 times natural log 2x plus 1. The 1 over 64 is the same thing as 1 over x squared, which is the same thing as 8 to the negative 2 power. Okay, remember 6.48. If you're confused with this, be looking at that video. All right, so now we have log base 6 of 8 to the negative second power. So it would be negative 2 times log base 6 of 8. All right, so that concludes the properties, and the next video will be the examples.